and go live. Okay, to people just joining this live stream, we are about to do a design review for geometry and graphics for the upcoming version of Wolfram language 12.3. So it looks like we have all kinds of interesting things coming here. All right, let's look at, first of all, at region dilation. So where should I look at that? Just
in the source.
DocuTools?
Yeah.
Okay. My first question is, how does this relate to dilation and erosion at the image processing level?
It's the same thing.
Then why has it got a different function?
Sorry?
Why is it a different function?
Because that one is specialized to pixel-oriented geometry.
Okay, you're going to have to sell me on that. Okay.
Well,
so,
we can rename it to Minkowski sum.
No, I don't think that's okay. Let's take a look at this. Okay. Okay, so how am I supposed to know? Okay, so if I were to do this, okay, so the region dilation, so I don't understand why it doesn't self-visualize here to begin with. So if I do that, why is it taking so long? Oh, that's cool. Okay. So there's no sense in which, wow. Didn't it have to, I mean, does it always have to do that internally, even when it's just going to generate a region visualization at the end?
Yes.
Wow, this is, I mean, it's magnificent, but it's awfully slow. What would happen if it was a mesh?
It would be fast.
So if, for example, if I take this and I turn that into, I say...
no, they both need to be meshes.
I understand, but you say...
it won't work at this time, at the performance. You are still working on it. Okay,
but I'm just trying to understand, because I'm trying to understand the analogy with dilation and erosion. So if I take discretized graphics there, if I were to take discretized graphics of the triangle, discretized graphics of the disk, okay, then what do I have here? Then these are self-visualizing things. So if I say region dilation of those, I will get presumably a self-visualizing, oh boy.
No, it's because, right, we have like disk, which doesn't auto-visualize, right? So if you return disk, you'll be disk.
Oh, wait, sorry, I did this. Okay, so why didn't this auto-visualize? So wait a minute, we've got two completely different things coming out here. Okay, so this is the analog of that implicit region, is that polygon region there. And if I now say graphics of that.
Or region.
Yeah, I understand. Then I will get that. Okay, so let me understand what happens if I now say dilation of this thing here. If I said dilation of this rather than region dilation, what would happen?
Dilation take an image, I guess you will complain.
I know, but I'm asking, why is that? Why isn't it the same function? Why isn't it the same function that can take regions or images here?
Well, at least from my understanding, dilation is for image, so essentially...
I know what you think. I know that you think that. Right? Did you read the documentation further? Yeah, go ahead.
Right. It's
okay,
working on Z2, right? Essentially, the domain image are essentially lattices, where this is on the Euclidean space on Rn.
Is Shadi here?
No. We can get her here.
Okay, so dilation here has an image and a kernel. Yeah, let's get Shadi, please. And what's the difference? So now you have, instead of an image and a kernel, you have a region and an R.
Well, R is just a convenience for a disk of radius R.
Okay, so that's the second argument here. But except that it's a range R square here.
Exactly. Because on
come on. Look, why is it a square here and a disk here?
because at least from my perspective, one case is, there is different dilation in different spaces. This is a special case of the Euclidean case for geometry, where
This
the
also
base
has
region is the disk.
This also has the interpretation, a distance r from the region.
Right.
Okay.
And in geometry, is equivalent to the sum of the region as well as the Minkowski sum, wherein, in dilation in image have a different interpretation, even though the concept in general is the same.
Makes me wonder if we should start pushing image dilation as the name for dilation here. So this is a kernel with structuring element Kerr, which is similar to
Kerr is just their way, because it's sort of this at first approximation. This works for black and white images, so they basically work. It's sort of an image implementation of region.
I understand that. I understand what it is.
And Kerr is a way to give sort of a micro region.
Exactly. It's your region 2, which is you're basically convolving region 2 onto region 1.
No,
correct?
You're adding them. You're not convolving anything.
Well, you're taking a kernel and you're smearing it out by taking this as like a Green's function of this thing, and you're integrating at every point. You're taking that kernel, right?
You're adding it on, yeah. You're not integrating. You're adding it.
What do you mean by adding?
In the discrete sense. In the discrete sense, right? The integration is the adding.
Yes, but I mean, you're going around the boundary. This is.
But look at the definition just below there. The set A plus B.
I understand.
Okay, that's the definition.
So it's symmetric in Reg 1 and Reg 2.
It is.
Is this symmetric in image and Kerr?
No.
Why not?
I think that they were thinking of it as kind of like a finessing operation. Do you know what I'm saying? You have an image that's dirty in some ways, and now you want to dilate it. I
understand. Okay, so listen. The design of this on its own.
But this has on its own very important use cases, just the sum of two regions.
I understand. This seems like a perfectly fine design on its own. I don't understand how it relates to this. We're going to need Shadi for that discussion. She's not available right now. So we're going to come back to this. Okay. So so Jezebel, you're the one doing notes here. So this we need to come back to in a subsequent meeting.
Yep.
Now, the UV mechanism here, where those are the sort of the scaling factors for Reg 1 and Reg 2. Why do you put those at the end like that? Why are they not sort of associated with Reg 1 and Reg 2?
How would you want to do that if they were associated?
I don't know. Arrows or lists or something. I mean, my only point is that I mean.
So there is by the way, if you have sort of 1, -1, some people call that the Minkowski difference. But there's another definition of difference too, which is the erosion difference, which is not the same as that. Okay, but both are useful and often frequently used operations.
I see. So you're saying, I guess I remember from many, many years ago that the whole, this place that did environmental something or other that defined all these operators. They had a whole, anyway, the early image processing stuff.
Sure.
Okay. So that's a reason to put those two together, that you are thinking of this as a modified dilation operator, where the operator specification is the UV pair. Right, so that's a reason to have that as a pair rather than to have it associated directly with Reg 1 and Reg 2.
Yeah.
Okay, I'm sold on that.
And the same goes for region erosion.
I agree. Is that what you've done with region erosion?
Yes.
Okay. I mean, I'm sold on that. That's fine. Okay, let's take a look at these. Well, I mean, I will say that as a increasingly serious user of this geometry and region stuff, many aspects of it are very nice. My major complaint is all of this, oh, you needed to discretize that region. Oh, it was the wrong kind of mesh. Understand.
We are aware.
I mean, so is that something you can fix
we're steadily fixing it, okay?
That's fine.
And so we're aware.
All right. Okay, good. Because I mean, I think it's just a question of things eating the right kinds of food, so to speak.
Yes.
Okay.
So this is your go-to version. If you write programs that use geometric regions, you want to use canonicalized region to not have to deal with so many cases in your code.
Well, it doesn't help me if I'm pattern matching, right? Or does it? Or do I just say _point and then I let canonicalize the region and deal with it?
Well, you could, yes. But the thing is that, like an example, do you treat do you have special...
I understand the issue. I mean, I understand that there's plenty of these special cases.
Many.
Why are you not canonicalizing a rectangle to a polygon? Or wouldn't you let people do that?
Well, that's more a conversion. Like we have canonicalized polygon. We should take a rectangle and rewrite it as a polygon.
By the way, why is it called canonicalized region, not region canonicalized?
Because
I see. You've got a canonicalized family with canonicalized polygon and things like that.
Right.
Okay, fine.
That's what comes out of them.
Okay. All right. Okay, fine. Oh, I see it. Yes, that makes sense. Okay, well, let's look at region convert.
Over time, there will be more forms here.
Okay, but if I want to solve a PDE or something, it should be able to take any of these things as food, right?
Yes.
Okay.
The solvers that we provide, they eat anything. If you have to program your own solver, you want to be able to get access to this.
Well, let's be realistic. If I take this and I say...
But you wrote your own solver, so you're the one dealing with it, so to speak. Okay.
Well, okay, but what I'm saying is if I take this and I say something like, okay, so if I say something like area, boom, it'll work. Okay, now let's say I say something like plot sine xy, xy element of that thing.
Plot 3D.
Magnificent. Okay. Now, what if I wanted to take that region and I want to make, how do I make a mesh from that region? Or do I need to make a mesh?
Sometimes discretized region.
How do I make a graph? Yeah, okay. So let's say I say discretized region. Now, why am I saying, okay, discretized region of that thing? Okay. As opposed to what would happen if I took that %9 and I said discretized graphics of that?
Discretized graphics mission has not been fully fulfilled. Yeah, so it works in that case. Well, it is graphics. But the long-term goal for discretized graphics is much more ambitious. We think of graphics as a giant unstructured database, a soup of primitives. Can you fish things out of that? Can you search basically in that soup? That was part of the original intent for discretized graphics that we will fulfill eventually.
What do you mean by search how? Search how?
Pick out the red parts. Discretize, get me only the red parts. Exclude this.
Why is that the function discretized graphics? Why is discretized graphics relevant to that operation?
Because graphics itself is a container of a whole world of unstructured things.
No, I understand, but why does that function? I mean, why isn't there a function called filter graphics or something? Pick out the red parts, and then discretize graphics is a separate thing. I didn't understand why discretized graphics is the one that picks out the red bits.
Question.
Doesn't seem right to me.
It's a possibility.
This
has to still be well-formed graphics what comes out. So
no, I understand that. I'm saying that I think it's an interesting idea to have something that is capable of treating graphics, doing graphics cases, for example, or something. But I mean, you can just do cases on graphics, but maybe you do it with other criteria. We have Shadi here. The issue that we're addressing is these guys have region dilation, and I am complaining about its failure to conform to what dilation does.
Mm-hmm.
I also have never liked dilation as a name. I mean, I always thought it should be image dilation.
The operation is really the same. Is there?
Yeah, but the structure is different. What about opening? Is there a region opening?
No.
What does it mean? Why isn't there?
We can add one eventually.
But I mean, it would mean something.
But it would have to have use cases.
No, I understand that, but I'm just checking. Is there a generalization of the concept of opening to?
Yes, there is, because
Okay.
it's defined in terms of those other operations.
Okay, so the thing that I'm pushing is why is there a separate function called region dilation that is different from? I mean, is there a region plus?
No,
Is
this
there,
is sort of region plus.
Region
Region dilation
region
is
plus.
basically region plus.
but there's no meaning to region. But there's a region difference, which is a different thing, right?
Region difference is complement basically.
Yes.
And unfortunately, yes, it's named region difference because many people have named it difference. I mean, in lots of CAD systems, it's the difference of regions.
Right. Okay, but the thing that I'm pushing is the slight, the bizarre differences between region dilation and dilation. Like, for example, the different choice of a disk versus a square. I understand why you're doing it. Range R square. I mean,
an arbitrary kernel can be specified as well, which would be equivalent to region 1, region 2 specification, the 2-arc form of region dilation. I don't know what's the 3-arc form there.
It's the linear combination. You can have a negative. You can have region A minus region 2.
Which you could also support for dilation.
Mm-hmm.
I would like to suggest something that I mean, dilation, opening, closing, they've always bothered me. They're really not the right names. I mean, well, okay, you're going to argue that they also work on arrays. Do they also work on arrays? Yes, they do.
They do.
But how do they work on arrays which are not just 0-1 arrays? Because like you're either in a region or you're not in a region. You're either, isn't this?
It works as a max operation or min operation for erosion. Same way as dilation and erosion work on grayscale images.
All right, I'm getting sold here.
These are pages that hasn't been overhauled. So these are the old style documentation that you guys did in image processing. They will be upgraded to modern.
Yeah, I mean, this is a very
versions.
nice picture. All right, fine. I'm sold. I do think you should harmonize things like putting in the UV arguments to dilation. Not a high priority, but something good. Now, what about padding option? That's irrelevant here, right?
Yes.
Okay, I am reluctantly sold. Okay, I have no objections. Should we move on?
Yep. Here's a cool application for region dilation.
Yeah.
If you want to solve a planning problem, like a robot motion planning, so
yes.
The question is, can you move this robot through
the
this
piano
space?
mover problem?
Yes. So what you want to do is to figure out whether when you
I get it. Yeah, whether when the piano is moving around, whether it hits, whether it can make it.
Right. And there's a whole slew of others called packing and cutting problems.
I wonder whether there's packaging that we should provide, top-level functions that we should provide that are more obviously related to that.
No, we will, but we're working on it. I'm working on it. So it's coming.
That's cool.
Okay.
That's very cool. All right, let's go on. So I have no objection. I mean, region convert and all those things, those seem fine to me.
Good.
Oh boy, photorealistic materials. Okay.
Yeah.
So Sander is saying on our live stream that he's looking forward to region dilation and region erosion. Good. He's asking, will they be fast on mesh regions?
Not yet. They will be soonish, but not yet.
Okay. All right. So this is a graphics directive, right? Is that correct?
Yes.
Goes along with shading.
Yeah. So it's a shading, like in the shading family. So it's a.
But shading itself, and by the way, I'm not sure Shadi needs to.
All right, I can drop off.
Is that correct? I mean, is there anything else for Shadi here?
No.
Okay, great.
Thank you.
See ya. Oh wow, I'm so out of date. Okay, so yeep, oh yeep. That's a really okay. So this is, it's like, why isn't shading pointing to like specularity? Okay, so that's what this is like. Material shading is kind of like specularity and things, correct?
It's a much deeper model. So here's what's happened. There's a consortium that got initiated 2012 between Pixar, Disney, Autodesk, and others to provide for a model where you can design materials and hand them off between different tools.
Yeah, I understand.
So it's a full modeling language for real-time but realistic shading.
I get it, but
so it's much more than specularity.
I understand that. I understand that, but as is always the case, we got to plug it into other things we're doing.
Absolutely.
Right. So presumably specularity. So if I give a pewter something or other, and then I choose to increase the specularity, that would still work. Or are we deprecating specularity?
No, that still works.
Okay. I mean, I think specularity is useful. Do you agree, or do you think it's?
No, it's useful.
Okay. All right. So let's take a look at this. Does this support entities for these things?
Yes.
So I can
most of them will.
As an element.
Yeah.
Well, at this time, it doesn't fully support entities, so that's it. We are discussing.
But we agreed that we would, right?
Yes, but not for this coming release. I mean, we need to actually gather the data and build it. Yes, that's in the plan.
I mean, our material properties don't store the properties that we need for these models.
Obviously, okay. Right. Yet.
Okay. So we've been in discussion with that team.
Michael.
Yeah.
So how? Okay, let me understand something. So is there a file extension for one of these material property files or something?
Yes, and they can come in XML, and so not for now, but we will eventually have an import format for that.
Okay. I mean, you can also then presumably you can say material shading of file blah blah blah.
Probably. That's not a bad idea.
But that's a direct graphic directive. Why do we want to import a file?
Well, because we need to, because it's something you're telling me there can be an external file that this is. So
we keep that later. I mean, so when we get to the the shading language we plan to extend is where that will actually appear, where you can actually import a a shader specification from another software, Maya and such, but you will not by default.
Okay, I think that's wrong. I think what should happen is the thing should. Okay, so here's a couple of comments. What is the output blob from this? If I just say material shading of iron, does it show up as a blob or does it just show up as a not evaluated thing?
As a blob.
So as soon as it's a blob, you could be importing from a file at that point. That's nice. That's nice. Quite nice. Very nice, actually. Boy, photorealistic, things like this. We've been waiting for that. People started asking us about that in 1988. And there's Beethoven or something.
And this is increasingly, I mean, what can be done in real time is kind of, I mean, it's still approximate in some sense, but they're pretty damn good.
Yeah. And you can do real-time rotation of this.
Yeah.
And how does this relate to our light sources? Okay, you faked the light sources here. So if I were to take
so we're going to add a new string. We need to add a new string value. I mean, you can use the default light source, no problem.
Okay, so
this is a 3-point light source. It's not going to look as good.
As opposed to what is this one?
A 3-point light source.
No, this one here, this one.
A 3-point light source.
You just 3-directional light.
Okay, but this is also...
This is called 3-point lighting. This is how you do interviews. Like if you see on the TV...
okay, I understand what you're saying. Yes, I understand. Okay. That's standardized, as opposed to our default lighting, which
is colored.
Has colors and so on, which would definitely not work for humans in interviews, although it would be amusing.
Right. I mean, they will look like a little purplish, but that, I mean, it might be.
It might be amusing.
You might get used to purplish looking people.
Yeah, purple people as opposed to eaters, right? Okay. So you're saying that for the photorealistic case, you would want to have lighting arrow what?
Well, actually, it would be good. We need to come up with a name for that, a string name for that. But it's basically got 3-point light. Just as we have neutral.
What's confusing about that is that, I mean, I would think something like studio will be better as,
But studio lighting can be flat. Most TV,
Okay, well then, but then I think it's too confusing. The reason I think it's confusing is that our default lighting is 3-point lighting. That's the problem. It has,
4-point.
I thought it was 3, but
or maybe it's needs. Well, okay, let's see if we can come up with a better name then. But they're usually
bluff. Okay. Well, I think it would be good to name it not. I think it would be good to have curated string names for things like 3-point lighting and whatever other. Just as when we have video fades, we'll have names for the the Ken Burns fade or whatever it is, right?
Mm-hmm.
Similarly, we should have industry names for these things, but I think we also should have common names for them.
Yeah.
I mean,
if you have a brilliant idea right now.
I don't know. I mean, I'm kind of thinking what you use this for is photorealistic rendering in some sense, or material rendering or something, or lighting arrow realism, material, I don't know. Something, because that's the case that you want it for, right? Is museum. I don't know if it is museum lighting, and that isn't quite right either. It's too whimsical. I mean, we want something where, because people who are doing photorealistic stuff want they're going to do this all the time. I mean, this is more like lighting a physical object as opposed to, lighting arrow physical. That doesn't sound right either. We need another name. I don't know what it should be. Okay. But it's something like physical or something,
right.
Because
we'll come up with something. Okay.
Okay. All right. Let's take a look.
If you have a brilliant idea, just email. I mean.
Okay. This is nice though. Okay. So then these things here.
So that standard doesn't come with actual design materials. So these are materials that we curated.
Okay. All right. So are we going to have, so I mean, as we know, for the color palettes, I really want to see those in a repository, and a lightweight repository. And these presumably are the same type of thing. They should be in a lightweight repository of materials. Do you agree?
Now we need something if we start to get lots of material, if we start to build lots of material, we need another mechanism. That's right, for sure.
So what I think it should be is just like the mechanism for neural nets, which is.
But the thing is that how the heck do you find them?
Well, that's the whole point. That's the whole point, Roger. That's the whole point.
But I don't think people find them. I mean, maybe they find them on the web or something. But
that's exactly where they find them. Okay, Roger.
But that's not what you're going to be in existence.
That two-step. Wait a minute. First of all, we're assuming everybody is connected to the web.
Obviously.
Okay. So what has happened with NetModel, which I consider to be very successful, is that you go, the workflow is you want a neural net. Okay. You can either know what it is or you can just say, let me go to the neural net repository, browse for my neural net, whatever it is, things like this. And then I just get it. There it is, NetModel of the thing. And, and now I can get that network. Right. And I think that's the right model. I think it's the right model for color palettes. I think it's the right model for these materials. So in other words, what this really means when you say material shading of silver, what that really means is that in the material repository, there is a page that looks like, that is about that material.
Mm-hmm.
Similarly with a color palette, instead of it just being some random name, and instead of you finding it in palettes here, you're finding it and then it is our responsibility to have a meaningful browse page like this, which depending on how many materials there are, how many palettes there are, we change what that looks like.
Yeah.
So I think that's the place to go. Now, in terms of in-product browsing, that is something that we need to work on. And Yazabel, this is something for some reason it's dropped off the agenda, but pioneered by System Modeler with its in-product browser for examples. We need to have an in-product browser for repositories.
Okay.
Am I making sense?
Yes.
Yeah, so that's the place to go with these, I think. And I think the thing to do is to start off with this kind of the El Cheapo, we'll just provide a few of these here that are documented right here on this page, and then expect to go to something which is a lightweight repository. Makes sense to you?
It does make sense. I mean, yeah.
Okay.
So we also thought that
what about entity?
Yeah, entity, we thought was another way to get to it.
Okay, what I think is the case is that you're never going to design, in here, you're going to have random tartans and all kinds of random weird stuff, right? You're going to have all kinds of random weird flecky things and so on, Those are never going to be entities of that type, I think. I think just like these things are not entities, these are sort of entities are things that sort of exist in the real world. So for example, chemical elements, absolutely they're entities. Edmund is asking on our live stream, would element entities get a material shading property? They absolutely should, and we should be able to do that. Of course, to be realistic, that's complicated because let's say you have an element, let's say carbon, right? As well, you're not just dealing with an element there, you're dealing with diamond, graphite, etc. But you're even dealing with, what is the cleavage plane that you're using, etc., etc., etc. And my guess is that for the immediate future, it will be much more relevant to have named sort of repository-like, materials rather than, we may be able to base them like sulfur, for example. What should sulfur look like? It depends on the preparation.
Yeah, but I think in real life, you sort of, yes, it might be educational and so on to get the various kinds of metals or and so on directly. But in real life, if you think of that this is portraying something, you want kind of like a dirty copper. You want,
of course you do, right? Which is
oxidized.
Exactly, which is why I'm saying don't go for entities, go for a repository.
Yeah,
because a repository is much more free. I mean, a repository, you put whatever you want in it. It doesn't have to be something that sort of relates to the world and has all of the, the same properties and so on. It's the right thing. I mean, linking some entities to this is a good thing, but I would only go so far with that. I mean, I would, as a courtesy, I would link some entities there, but you're never going to get all the different forms of iron. You'll have some generic iron that comes from that. Make sense? I mean, you can have all kinds of weird things. I mean, you could have, Mars, right? We now know that Mars, looks like I used our image identifier to say that's that geolocation image identifier, the one that says where a photograph is. According to it, the Perseverance rover is somewhere in Egypt. So you could start a conspiracy theory from that.
Oh yeah, great.
Okay.
The other thing is that there is a monograph coming that describes this underlying shading model, so it's easier to then design more.
Okay, but I think this is wonderful. So let me ask a question. So these things are fundamentally okay. There's an association, and are these values kind of constant values? Those are just colors,
right? In the next revision, we would like to extend this to be varying things, and they're going to vary by providing a texture.
Well, it's actually already documented downstairs. So the value can be a color, a texture, or a texture plus a multiplier factor function.
I see. Well, that's another reason you do not want to go for entities. I thought you were going to have tartans, and you are.
What's tartans?
Oh, I just, these Scottish, iconic, whatever. I mean, just these crisscross patterns.
I see.
Which have nothing to do with the material. A crisscross on copper isn't really okay. What is this normal? What does that mean? What does normal mean?
Is the normal vector to the surface?
Normal vector.
But why is the value 0.8? Why isn't it a normal vector? I don't understand that.
Right. So there is the normal vector you can give. Usually they give it as a texture, or we can also take a numerical value to kind of amplify it.
So that's a multiplier of the natural normal vector. I don't understand why this is called normal.
It should probably be normal weight or something.
Yeah, this just doesn't seem right. Normal multiplier or something like that.
It's presumably it's in the shading equation, presumably.
Well, it's essentially the normal vector. So we could have written.
But it's not a vector.
It's not a vector.
No, hold on. It's a normal vector, but for convenience, we can also take a texture, which also encapsulate that normal vector in the RGB color. Is what usually people do.
Yeah, but your illustration.
But also there is. Correct, but you see also in the illustration, there is a second argument, comma S. Sure, we can fix the illustration, but there is also a fraction, in fact, to amplify an effect, right? You can have a texture and you want to amplify the effect, right? Is that illustration team added there? Maybe we need to adjust the illustration, but it doesn't mean that the spec is wrong.
Okay, what is the value for normal? What is it supposed to be?
So by default, the normal is a vector. In this case, a 3-value vector, right?
Okay.
Vector.
But
it is. Then it should be. Maybe we should call it normal vector.
I think so. And I don't understand this. I mean, documentation-wise, this should surely say normal vector arrow vec or something, metallic arrow. I mean, a list of vectors or something. So we're not just, I think these should say what their right-hand side is.
Well, we put it below. We say the value because the value can be a color, it can be a texture, it can be a list of color.
But where's the for colors palm eye? Oh, okay. Possible colors palm eye are this fraction of the color contribution to the final color. I do not understand that.
So in some case you can make it red, but you want it, roughly speaking, like dilute that red in the contribution at the end. So you can make, half of that color will apply at the end, which give a nice effect. It's more a convenience and flexibility parameter.
I think I need to understand this a little bit better. Let's see. Jari is asking, do these materials work well with exports to realistic renderers? What's the answer to that? In other words, can you, I mean, we're going to have a pretty good renderer here, but if you wanted to have really fancy ray tracing type stuff, can you export this? I presume the answer is yes, because this is coming from some standard rendering format.
Right,
Guys?
but we don't yet support those file formats. So probably some of the file format step and such, as we introduce them in the future, we definitely support this directive.
Right. Okay. So, by the way, can we have transparent objects as well here? Does this support that? These are all not just surface properties.
Not yet at this release. Probably in the next release, we'll work on the transparent.
So the problem is like subsurface scattering.
Yeah, I understand.
Okay. So it's not beyond the scope. It's just more work to get it right.
So is there going to be fur and things as well?
Don't know about
fur. Close to, there is a velvet there, which is...
Yeah, velvet is a little bit like that.
Okay, can you go full fur, so to speak, and make them hairy and so on? And because that involves a bunch of diffusion level, diffraction level, light scattering and so on.
Possible in the future if there is a
okay, all right, fine. But this is impressive enough as it is. It's very nice. And I guess it's good to have some of these, known iron, bronze, fair enough. I mean, these are cartoon irons and bronzes. They're not necessarily what a real, iron heated to such and such a temperature, glowing, whatever, red hot iron. By the way, you should have those. That would be a cool one. Red hot, materials and things. Why not? Just a suggestion for how to get something sort of spectacular. Make sense?
Sure.
I mean, you can have it glowing, right?
Yeah, everything is a model. So you can build up a model.
Well, I understand. It's a question of where the model can go, because subsurface scattering is not where it can go.
Yes, so there's emission color, so you can actually do that at this stage.
Right. Nick was asking about whether procedural material capture. Oh, this is okay. Right. So this is essentially a graph. The thing Nick was pointing to is essentially a graph for procedural generation, and presumably that goes beyond the standard, but this standard will already get us a fair distance.
In their model is a DAG. Yeah, it's a special graph.
This is the one that Nick was pointing to. Convert photographs into production-grade procedural material models. That's interesting. That's an interesting thing to do. So that's a machine learning story going from a photograph to material properties. That does seem like a worthwhile thing. If nothing else, that should be some kind of internish project. Seems like a good idea. All right, let me add that. Jezebel, if you could.
Yeah, I noted it. Yep.
Okay. All right, fine. You can send it back to me and I'll add it to the list. Okay. We're going to run out of time here, but I just want to do a quick preview of what we're going to see. This is really cool, by the way, guys. Very nice. Should we look? I mean, I'd like to do one careful look at the names of these things. Are these names part of the standard, or are they your version of those names? Guys?
I mean, it's pretty much our version of the names, but most of them, I mean, base color, emission color are kind of standard names. So if you pretty much get any software which does that, you will see base color, emission color and such. You will see metallic, roughness.
By the way,
normal.
Sandra is asking for a specific thing for that, which I think is a little bit of an ask, but I think we should be able to get here. In that, I should be able to say gold, right?
Yeah.
I see. So with default, and another suggestion that Sander or somebody was making on our live stream is if we see, for lighting arrow automatic, if we see a plot style that has material shading, why not change the lighting? Seems not a totally silly suggestion.
I agree.
Because this isn't looking very good here.
No.
What would be the correct lighting here?
Well, you try neutral to begin with. At least be better.
Yeah, it's not great.
No.
Well, so okay, fine. So we should just change the default in the case where there's material shading, because there's got in a plot 3D at least.
Mm-hmm.
I suspect whenever there's material shading, it will not look good unless you have the fancy lighting. That doesn't look particularly good either. Is that because basically, I mean, is that because these kinds of surfaces basically just don't look very good? We're not, as humans, we're not very used to seeing these things, and they just don't look very good. I mean, explain that to me. Do you understand what I'm asking? I mean, because this is the issue that we had back 30 years ago when we were considering doing photorealistic rendering, for all kinds of mathematical type things, is it just didn't look very good.
Can you add plot point goes to maybe 80? Let's increase the number of plot points.
It's okay. But I mean, frankly, I'd be happy with this just being yellow. Right? I mean, honestly, I don't think that's I don't get anything for it being the gold material here.
No, I don't think that that's the big use case. I think that there are two other, classes of important use cases. So one is when you model real world things.
Sure.
So solid modeling, for instance, and anatomy is another one where I think it might be useful.
Yes. And also 3D printing, pre-visualization, yes. Those kinds of things.
Right.
Can I put something, sorry, can I put one of your complicated fancy ones in here? How do I get that one?
I think there's probably a rasterized in there.
No, I understand that, but I'm asking, how do I?
Isn't there one down there that you can just pick up? Charles, is there one in the examples?
So you mean what, the model?
Yeah, that notch that you used as example, or just anything a little bit. We could use any knot, can't we?
No. I didn't mean a knot. I meant I can do a knot. What I was asking for was something, a more complicated material property with more complicated roughness or something like that. Well, let's try velvet. Yeah, this isn't really doing it for me. I mean, so what? It's basically, this just looks green. Now, on the other hand, okay, so this is actually very interesting, visual perception issue. So the claim would be, if I were to do a knot, how do I do that? If I do knot data of, let's say, 4.2, oops, 5.2. Okay, there's a knot. So now how do I get that? How do I show that in the with those material properties?
Oh, it's well, you can do image data to get the graphic, and then you wrap it around graphic.
Well, let's see. Doesn't knot data support?
Not as far as I know, we don't add any styling or such.
We should probably support that, particularly for this case. Okay, so now what do you want to do here? So now I just say graphics 3D of, let's say, material shading velvet. of that, and that's going to be default lighting. Okay, that's more interesting, honestly. It's better than these surfaces. I mean, that's more usefully, whatever.
Yeah.
I think us humans are just wired to not care. If you give us a non-real world thing and you try and cover it with real world stuff, it doesn't work very well.
Right. But I think we are getting increasingly, more use cases in the system. I think solid modeling, geometry, printing, and so on are examples of that.
Well, yeah, and just presentation of things like this. I mean, I'd like to see some hypergraphs in Velvet, for example.
Right.
Somebody's been pointing out.
Yeah, that would work.
The physics of the rule for the universe should be published in gold, so it can be called the golden rule. Yes, needs physics simulation to make it more realistic. That is coming. That is coming. Okay, we need to wrap up here.
So you've covered everything. The rest is relatively small.
Really, I think we'll need another hour.
Okay.
Fine. This is very good.
And we'll schedule that. No problem.
What's really the fuzz which will need a GPU? Is this being done on the GPU?
Yes.
Is this being rendered on the GPU?
Yes.
Yeah, I would think so. Otherwise, it wouldn't be able to rotate in real time. Right, very nice. And I mean, what about some textures here that are a little bit more, just what are you planning in terms of the texture repository, the material repository, in terms of what type of things? By the way, are you sure it should be called? Yeah, I guess it's called materials, even though the material might have a pattern in it. Do you see what I'm saying?
This is what these things are. These assets are,
right. But I think fabric should be. I mean, I think you should plan something where there are obvious kinds of textures that people might want. I'm trying to think of what types of textures there might be. I don't think you need an asteroid, not a not-shaped asteroid, not-shaped.
Maybe we need to do like these other companies that they have job titles, which are basically material designers. Those are most of the people we see.
Right. Well, I mean, I think we just need to find out, is there an analog of the Thingiverse for materials?
Yes, there are several repositories of material or pretty much texture, as they call them.
So we need to curate the ones that are interesting.
Yes.
All right. I need to
provide an interface to them. So.
What's that?
Or provide an interface to.
Yes. Well, yes, but look, I think it's much more useful if we curate them, and so people know what to expect, and so they have reasonable names, and you can, show them on a browsing page, et cetera, et cetera, et cetera. Anyway, terrific stuff. I got to run. To be continued.
Thank you.
See you later. Oh, actually, there's a comment from Monk, which is worth reading about light sources and how to position light sources. But I have to run.